Welcome to a general introduction to machine learning using scikit-learn. In the course, we're going to learn how to use the library in Python called scikit-learn to build predictive models. Predictive modeling is a subfield of machine learning that focuses on building models that make accurate predictions. We are on the verge of an explosion in predictive analytics, and Python is emerging as the language of choice for education and real-world predictive modeling. In the course, we're going to focus on the library called scikit-learn. A library is just a bunch of code that's separate from the core language that we can import to extend the functionality of the language, and in our case, our language is Python. In the course, we're going to build an end-to-end model that explains every line of code. An end-to-end model means we're going to cover every aspect from importing our data to building the model and determining the accuracy of our model. We're going to cover the vernacular of predictive modeling as we move through the course. In the course, we're going to skip the math and focus on the model building process. We don't need to know how the algorithms are written to build highly accurate models. We need to learn how to model and to master the well-documented scikit-learn process that will help us craft highly accurate real-world predictive models. Thanks for your interest in a general introduction to machine learning using scikit-learn, and we'll see you in the course. All right, this lesson, let's talk about the course goals and what you'll learn upon completion of the course. Let's start with the course title. The course title is A General Introduction to Machine Learning Using Scikit-learn. So this will be an introduction to machine learning using scikit-learn. Well, that's great. What's machine learning? Machine learning is a method of data analysis that automates analytical model building. Using algorithms that iteratively learn from data, machine learning allows computers to find hidden insights without being explicitly programmed where to look. All right, so now that we know what machine learning is, what's scikit-learn? Scikit-learn is a group of libraries that extend the functionality of the Python programming language. These scikit-learn libraries are used specifically for machine learning in Python. Python is one of the most popular machine learning languages used for building ML models. In the course, we're going to build an end-to-end model using random forests that will help us predict if a customer will purchase a bike or won't purchase a bike. An end-to-end model simply means we work through all the steps needed to build our model from start to finish. The project will include a data set. That means our project will be a supervised learning project. So in summation, in the course, we're going to be using Python's machine learning libraries, specifically scikit-learn, to build an end-to-end solution that will help us predict the likelihood of a customer purchasing a bike from a company. All right, in this lesson, let's talk about course overview and a little bit about the differences between machine learning and data science and what we're doing, predictive modeling. In my highlighted cell there, you can see that the course is going to focus on a specific subfield of machine learning called predictive modeling. It's a type of machine learning that the scikit library in Python was designed for, and that's why we're going to do it. We're going to create predictive models. The next line is really key. Predictive modeling is focused on developing models that make accurate predictions at the expense of explaining why predictions are made. Right? You and I aren't necessarily going to know how these models are built. We're not going to write the code behind a neural network or a linear regression model. Right? We're simply going to use the model as it exists. We don't need to know what's in the model. We need to take the model and apply data to it and then interpret those results. Most commercial data scientists, or I should say machine learning guys, or those of us who want to work as data scientists, are going to be focused on model building. Companies are going to hire us to build models, interpret the models, and then allow their business users to use those models to make accurate predictions against the data. Almost all of the commercial predictive modeling is going to be supervised learning. And that simply means that we're going to start with an existing data set. All right. So let's move on to the next cell, which is called course overview. All right. So what are we going to do in the course? We need to set up our environment. All right. We need to import our libraries and modules. Remember that Python is the language, but we're going to need to import sklearn or scikit-learn. Right? Scikit-learn are libraries that we're going to use that aren't automatically installed with Python. We're going to load and cleanse our data set. Right? That is going to be the most time-consuming aspect of your job. Right? Getting the data set and cleansing it. And you're going to see right away that even though we start with a really clean data set, when we import it, it's going to fail. And you and I are going to have to find out why. Next, we're going to discuss pre-processing. We're going to look at cross-validation. We're going to evaluate the model, and then we're going to save the model for future use. Now, I don't want to go into what pre-processing and validation and all that means because we're going to do that in the course. In this lesson, I really wanted to make the point that what we're going to be doing is modeling existing algorithms against a company's data to make predictions. In this lesson, let's talk a little bit about why we're going to use scikit-learn and why I like it. You can see in the highlighted cell, I have several reasons on why I like it. And these come from a blog post by Ben Lorska on using scikit-learn. And he is the chief data scientist for O'Reilly Media. And he walks through why he uses scikit-learn. Now, I love it because I think Python is the easiest and most intuitive language I've ever used. And I think you'll feel the same way once we get started. For now, I just want to show you an example of their commitment to documentation and usability. One of the most difficult things for you and I when we get started in machine learning or predictive modeling is picking the right algorithm to use for a given scenario. Well, the guys at scikit-learn have created an infographic for us. Let's take a look at that. And let's search for it as scikit-learn, scikit-learn. And if we search on scikit-learn cheat sheet, it's going to take you to that URL. We're going to click on the URL, and this is our cheat sheet. And this is too big. So what we'll do is knock this down a little bit. We'll come down here, and it kind of gives you this path to take for finding the algorithm to start with. So at the start, we go here. Do we have lesson samples? Sorry, we need more data, right? Are we predicting a category? Is our data labeled? For you and I, most of the time, it's going to be yes. So we're going to be in this classification space often in the real world. Now, the thing I like about this is, let's say we go, okay, I want to do a linear SVC, right? So we click on that, and it takes us to classification and linear SVC and some examples of how to use it. Right? Notice how clean this is. Right? Their documentation is fantastic. Let's go back to our development environment. Yes, believe it or not, we're going to talk about this URL we're in called a Jupyter Notebook. This is actually our development environment. So I don't want to spend a lot of time on walking through why we're going to use it. I just wanted to show you the infographic because it really gives us a starting point on where to start looking when we have a problem for our machine learning projects. I encourage you to click on the link here and read the full article. It's very short, but very informative on why he uses scikit-learn on many of his real-world projects. All right, in this lesson, let's learn how to install Python. Now here we have a Jupyter Notebook, and recommend you just click on this URL, but you can't get to the Jupyter Notebook without installing Python. Now, Python used to not be so easy to install. However, it's now very much a click, click, click on both major operating systems, and those two are Mac and Windows. So how do we get Python? We type Python and Anaconda. And the first one we get is download Anaconda now from Continuum Analytics. And this is the page we want to navigate to in order to download our Anaconda distribution. And it really is easy as navigating down to the bottom. And we want Anaconda 4.3.1 for Windows. And you notice we have two versions. We have this 3.6 version and we have this 2.7 version. Now, most of the time, at least if you're in the Windows world, you always like to go forward. You don't like to go back. However, most of the real world models are still being built with Python 2.7. So we're going to go with Python 2.7. So download this for either Windows or download it for Mac. And I guess I did forget to mention, you can also download it for Linux. And of course, like I've mentioned a few times, we're going to download it for Windows. And it really is as easy as downloading the installer and installing it. As one of my friends says, it's a click, click, click installation. Now, the only trick is, let me close this. We need to be able to start our Python notebooks. And our Python notebooks are our development environment. All right, so in order to do that, that's a little different. Right? We don't come here and then search for our applications like we're used to in Windows. We come here and we type command, CMD. And this opens to the user's West. And this is where Python is installed. Well, it won't be West for you, but it'll be users in your name, unless you change the location of the installation. And I don't recommend you do that. So the IDE, or the development environment we're going to code in, is actually a URL. And in order to get to that URL, that thing we call a Jupyter Notebook, then you have to open it. And when we type JUPY, Jupyter Notebook, it opens the notebook. Now, one little caveat here is that once it's opened, right, you don't want to close. Let's go back here for a second. He needs to remain open because this is the server on your laptop, right, or whatever machine you're using. This is actually running this. So if we close this down, it disconnects, right? All right, so that's how we install it. We're going to talk about the Jupyter Notebook in the next lesson. The only thing I wanted you to keep in mind was that when we do our CMD, we need to keep our Python window open. All right, we can't close it. And in order to create a new notebook, we want to come to New, Notebook. See, it says here, Python Notebook. And it's going to open a Python notebook for us. And error, when created a notebook. Why is there an error? Because it looks like I shut down my command window. So let's go to the command window again. Let's type in Python. Let's type in Jupyter Notebook. Hit enter to start our server and to pull up our Python window. Now let's try it. Let's come to New and let's create our Python notebook. And this will bring up our Jupyter Notebook. Right? And this is actually our development environment. This is where we're going to type code. Right? And in the next lesson, we're going to cover this notebook. All right, in this lesson, let's talk a little bit about the vernacular of the data set. Every field has its own vernacular, and machine learning is no different. So we're looking at a results set. The term results set comes from the relational database world. In machine learning, this is called a data set. In the header, we have column names. In machine learning, column names are called features. The rows are called observations. That thing we are trying to predict is called a target variable. In our example, we're going to try to predict whether a person is a bike buyer or not a bike buyer. The column called bike buyer on the far right-hand side is our target variable. We're going to use as many pertinent features as we can to make that prediction. We can see that we have a 1 and a 0 in our column. The 1 represents a person that bought a bike, and the 0 is a person that did not buy a bike. Some features aren't going to help the algorithm make its decision and may even hurt the model's accuracy. For example, we've listed the customer's occupation in different languages. Since these columns have no value whatsoever, we're going to remove them. The decision on which columns or features to keep or remove is called feature selection. Since this data was exported from a relational database, we could have easily removed the features before exporting the data. However, because we're learning Python, we need to know how to do it in Python, so I left them there. All right, in this lesson, let's learn about the Jupyter Notebook. The Jupyter Notebook is our IDE. An IDE is an integrated development environment. It's where we're going to write our code. How do we get there? For Windows, let's come over here and type in CMD and hit enter. And let's type in Jupyter Notebook. And hit enter again. And now we're going to get the home page. It says home, and it's a URL. And in order to open up a clean notebook, we come here and we come here, we navigate to Python 2, and we hit OK. And this is a cell, and this is our Jupyter Notebook. So the first thing we want to do is let's name it. So we just click on that. Just actually double click. It brings up this dialog box, and we'll call this our first, I was going to say Python notebook. We'll say OK. And now we can see it's changed the name to our first Jupyter Notebook, right? So this is a cell, and this is where we type our code. A nice thing about this is we can also document what we're doing. So notice here it says code. If we change this to Markdown, and we come down here, and let's type in, how about a £sign to make it a nice large header. Then we'll say, let's get started. Let's get started. And every time we want to execute a cell, we hit the control button and the enter button. And now that's run successfully. All right, now if we want to come up here and run some code, we go to the next cell. This adds a cell. And when we're highlighted here, we don't want the cell, we just delete it. We cut it. The scissors gets rid of it. Right? Let's write some code. Let's import pandas. Pandas is a library as PD. We're going to import pandas. We're going to alias it here as PD. So all you have to type in as PD to be able to use panda. Control again, enter. It's running. You can see the little asterisks, and now it's finished. You can also run your code up here. Let's put that there and hit the enter. And it will execute and move to the next line. We can move our cells up and down. All right, so let's put our highlight there, and let's move the cell down, or move it up in that case. Let's move it down, and now we can type something else in here. Let's type in some more documentation. The import means the word import means to bring in to Python, to bring in a library into Python. All right, shift enter, and there we go. All right, so what are some other things we can do if we wanted to stop? We're executing some code and it's taken longer than we anticipated. We could come up here and hit the stop button. Right? We can insert. If we didn't want to add, we can highlight our cell, right, and insert above or below. Right? Let's come up here and type something. Let's say backspace 1 plus 1 plus 2. 1 plus 2, and we hit shift enter, and it gives us the output. Now let's say we've done this the whole way down. We've got a big long list of code, and we want to clear the output. So let's come up here to cell, current cells, clear. current output, clear. And that will clear all of our cells. And I promise you'll use that later. That's really a handy feature. All right, we can save anytime you want. This is kind of like forcing a save. It will auto-save every few seconds as you're working through the code. But again, you can force a save anytime you like. All right. Let's move back to the home page for a second. We have what we can see on our home page what notebook is running, or notebooks. So let's come down here and we can see our first Jupyter notebook is running. So we can highlight on this, right? Click on it, and we can come up here and we could shut it down, turn it completely off, and we could delete it. So let's go ahead and shut it down. Let's go ahead and open it back up. And it'll open up from scratch. Let's say we did this. Let's go Control Enter. This is how you're going to execute if you don't want to continue to hit this all the time. Most people will hit Control Enter. So let's go ahead and Control Enter. And there's 3. So this looks like it's run. And if we were to shut it down, right, it may save this for us. However, if we have a whole bunch of code and we start this again, each cell will have to be run, right? Once we close this window, right, this is our Python server. We close this, it shuts everything down, right? If we come up here and we see this, just like this, it's not been run, it's not been executed. You're going to have to step through the entire process again, right? Or you can run all the cells up here if you like, right? All right, so let's recap. So these are cells, right? In cells, we can type text. We have to come up here and say markdown in order to type some text in here, right? This cell, we have code, and it says code, so we can type some code in there. We can hit Control Enter to execute. We can also hit this little button here to execute, and that'll take you to the next line, right? If we want to come up and cut a cell, we use the scissors to cut a cell. We can easily add a cell by hitting the Add Cell. And if we want to save our entire workspace and we want to force the save, it's called a checkpoint, we hit the Save button. Right? If we want to clear our screen, we come up to Cell and Current Cells, and we clear all the cells. Right? As we go through, I will show you some more hints to work with our notebook, but that really is about it. That's all we need to know to get started building our model.
All right, in this lecture, let's learn where to find our course downloads for the course. There are only 2 things, but they're critically important to the course. So if we come here to the curriculum for the course, and we come to the next lecture under Jupyter Notebook Anatomy, we have course downloads. You'll go to course downloads, and you will open up. Let's go to my desktop to find where I put it. Obviously, you'll download it, and it will be in the download section. And then you'll open it up, and it will say scikit. You'll have these 2 files, Control on both of those, right-click, copy, and we want to place these in the directory where you installed Python. And for me, that is going to be, see, users and West. And you'll simply paste these right there, right? All right, let's go ahead and open up Jupyter CMD. We'll type Jupyter Notebook. We'll hit Enter. It will open up your Jupyter Notebook. And under here, under your home directory, say home, there'll be a notebook called A General Introduction to Scikit-Learn, right? You'll click on it, and that'll open up the notebook with most of the course and the code right here.
All right, in this lesson, let's take a step back and look at the picture in its entirety. So what you're seeing in front of you is the entire end-to-end process for creating a random forest classifier and the results. You can see at the results at the very bottom there, right? For this data set up here, the BBC data set, we have a 78.146% accuracy. So 78% is not bad. All right, so let's step back and look at the items involved in the process. So what's the first part? The first part is up here. And what is this part? It's the importation of the various functions we need for our model. So if you look over on the far left-hand side, we have this from, right? All these start with from, every one of them. From what? From a library. In this library, from pandas, we're going to import, means to bring in, this read CSV function. And actually, we're going to use that read CSV function, CSV, this file name. And this is the file we've read into that variable. And a variable is just a container. Right now, that file name container is just holding the contents of this BBC CSV. CSV is a comma separated values file. We're going to see that a lot in machine learning. So up here we have the very top, NumPy. NumPy is another library we're importing. And then finally, we have sklearn, right? So we're using three different libraries here, right? We're using pandas, NumPy. NumPy is numerical Python, and sklearn. All right, so we'll talk about what the libraries are for later, but we start at the top by bringing in or importing either the entire library or we're importing a function or other objects that we need for our model. As we move down, we're going to need a file, right? So up here, these are our libraries. And remember what a library is. So here we have the language, right? That's Python. And here we have all these things on the outside that we can import in to our language to use, all right? So we're importing three things. Well, we're actually importing items from three things, aren't we? Or objects from three things. Pandas, NumPy, and sklearn, right? Remember, all these do is help extend the functionality of our core language. That's all they do. All right, so we're importing the things we need for our model. Next, we come down and we need some data. Remember that most machine learning problems in the real world are supervised learning, right? Supervised learning means we have a data set. So this is our data set, all right? That bbc.csv. Now you're thinking, well, wait a minute, it's reading this CSV, this file name. How does it know you don't have a path? Well, because we put this file name here in our default directory, it knows to look in the default directory for that CSV, right? So we've got the two parts of the process. We're bringing in our libraries, number one. Number two, we need some data. And number three down here, we need an array. An array for this example is going to hold our data, our X and Y. Here, it's going to hold 0 is the first value and the 11th value of our data set. Here, the Y value, this is our target variable. All right, let's go down and show you. Let's move down to the next slide. Now we can see that this is our data, right? This is our data set. Keep in mind that earlier in the course, we said these are not columns. These are attributes. So what we're going to do with all of our machine learning is try to predict this thing at the end. That's our 𝐏𝐫𝐨𝐼. That's our target variable. That's what we're going to try to predict. That's our target variable, all right? We're going to do that with all these other columns. Now, something that threw me when I looked at this, and if you start counting from one side to the other, you'll see that this is column 1, and then this is column 12. Well, in NumPy, which we're using, we've imported up there and we're using NumPy, 0 counts. So over here, right, let's come over here. You can see there's a 0, right? All right. 0 is right here, right? That's 0. Now this is 1. And if we do it that way and we come over here, that column on the far side, he is 11. He's our target variable, right? Come over here. Where's our target variable? Where's my little pen thing? He's our target variable, and he's the last column in our array, right? 0 being the first. So that threw me a little bit. I hope that helps. All right, so let's move on to the next slide. All right, at the end of the last lesson, we were here, and now we need to delve down into testing and modeling our classifier. And classifier, by the way, is the term that scikit-learn uses for the algorithms, right? It's just the, for example, a 𝐾𝐫 classifier, a random forest classifier, right? That's just their terminology. So here we've got a test size, right? We need to test our data. We split our data up into 2 segments, right? One to train and one to test. There's trio, TR, and TST, and we do this so the algorithms can't cheat. And usually we split this up in about an 80-20 fashion. I think the default for, now don't hold me to this, I think the default for scikit-learn is the 75-25. Either way, when you specify this, which you end up specifying as a parameter here, where's my little thing? My little thing's not moving fast enough. Right, test size equals test size. That is this test size here. All right. And this test size is going to be over here, right? The training size is obviously going to be 70%. Over here, we're going to hold out 30%. All right, so the testing is going to be on 70% of our data set up here. All right. Over here, we've got this random seed, and this is strictly for reproducibility. And as you can see over here, we pass our random seed. See how straight a line I can draw? Oh, that is bad. Either way, you can see right here, our random seed is passed here. Now, the syntax for scikit-learn is xtrain. Now, this, I didn't make this up. This is just something you've got to pass in, right? This is just the syntax for how to create a train test split. So we xtrain, xtest, ytrain, ytest. We say equal to our x and y, and then we specify our seed, and there are obviously other parameters here we can pass in. Right now we just have the test split and the random seed. All right, this down here. All right, because it's part of the model building process. So here we say model equals, right, whatever model we want. And you'll see later on in the course that we can simply pass in any of these models we have brought in. So I could really just replace random forest right here, right? I could cross out this word and really just type in 𝐾𝐫𝐨𝐿 classifier, right? And I could leave this right here, right? Because they're all functions, right? And it will run because this is just our variable, right? So all we have to do in order to create and test a new classifier or to train a new classifier is to type the word. Now you'll see me do this later. Now here I've brought in a random forest, right? A 𝐾𝐫𝐨𝐿 and an SVC. So all we would have to do is replace those words, and you'll see me do this later. So if we wanted to say model is equal to SVC, we would say model equal to SVC, right? And that is our function. And then we could just run it. So we need to fit, right? Model fit xtrain, ytrain, which we get from up here, right? Pretty straightforward. The result of our model is equal to xtest and ytest, right? Again, syntactically, this is pretty straightforward. And we're going to print the accuracy of our model, right? And the accuracy will come out there. Again, accuracy is used quite often in classification, and we'll talk more about that later. Now, this isn't scikit-learn's process that they've lined out where they go 1, 2, 3, this is what you do. No. I think if you look at this and you say, okay, in any model we create, we're going to do the same thing, right? We're going to do this first. We're going to import our functions or our modules to use. We need some data, right? Because most of our examples are going to be supervised, not all, but most, right? We're going to set it to an array. We're going to need some testing and training split so the model doesn't cheat. We're going to need to specify a model, right? Here is a random forest classifier. We're going to need to fit it, and we're going to need to get the results of it, right? So this is just a high-level overview of our processes. I think going forward, this is probably going to help you with what's involved in any model that you build. All right, in this lesson, I wanted to tell you what I mean by canned data. Now, no matter what tutorials you'll go over, you'll find that the data is canned, and that means it's been cleaned. And we'll come down here. We've got our file name is this CSV file, and we'll click here, and we'll say Control Enter, and it'll just load. So that'll be great. All right. However, that doesn't happen all the time. And as a matter of fact, let's come over to Google and let's go find another famous data set to play with that you'll see used a lot in tutorials. It's called the Pima Indian Diabetes Database Set. And if we click here, it'll take us to UCI Machine Learning Repository. And in this repository are a whole bunch of other data sets that are really clean. And if we open the data folder here to get our data, and we say, you know what, I'll take this one right here, right? And it opens, and that's clean, right? There are no holes in the data. It's all numerical, which means it's ready for us to put right into our algorithms. However, that really isn't real life. And even this data set that I'm showing you over here, I've cleaned. Now here's the data set I exported from SQL Server. And you can see I exported from AdventureWorks DW 2012. Now, if you're unfamiliar with SQL Server, that's all right. The AdventureWorks database is just a tutorial database, right? And the DW and the AdventureWorks DW means data warehouse. And this is a view, kind of like a virtual table, right? And these were crafted specifically for data mining. So it's going to carry over really well for us. And again, look how clean it is. Even though we have text that we have to clean up, right? We have our target variable over here. And the target variable is already a 1 or a 0, right? It's a binary classification problem, so that makes our job really easy. So what's the point? Well, the point is in the real world, this isn't going to happen, right? As a predictive modeler, the data is going to be dirty, and the majority of your time, to the tune of 75% of it, will be trying to get to this point, trying to get to a data set that's usable for predictive analytics. All right, so I just wanted to point that out. I thought it would be unfair for you to go through this learning process and think, oh, everything is just working with the models. Everything is learning about the differences in the algorithms and making. All right, in this lesson, let's move to the model building process. All right, so I've added a few other things in this notebook which you're going to receive a copy of. And what you're going to do is take this notebook, this specific file, and you're going to put it in your working directory. And when you open Python, it will see it on the home page. I'm going to show you how to do that later. But for now, I wanted to tell you that I've changed a few things in the notebook. So I've added information in the notebook alongside the code. So here we have some information on how machine learning fits into the world of data science, right? And I will let you peruse this. I'm not going to read this to you. Here, when we navigate down to the model building process starts now, that's a good indicator that we're going to start building our models. So let's go ahead and start that now. So I've structured the notebook so that information about the code is above it in text. All right, so here is our cell that we're going to run. That is Python code, and here is text about it. The same thing for these 3 cells. These 3 cells have something to do with the code directly below it. So here on this cell is our first Python code, and we're going to import pandas. And actually, from pandas. Remember, we're importing something from pandas. What are we importing? Here, these functions. Could we import all of pandas? Yeah, sure we could. It's not the Pythonic way, but we could. Let's highlight the cell. Let's add a new cell. Let's come down here and say import pandas and hit Control Enter. And now you've just imported the entire library. All right, again, not the Pythonic way. So we're going to cancel out of this. And for the upcoming lessons, all we need are read CSV and the set print option. So let's go ahead and hit Control Enter. And we're done. One of the strange things about working in these notebooks is you don't get any results. So when we hit Control Enter and nothing happens, your first impression is, well, did it work? Yes. So it won't work if we do this. And we've misspelled print options, and it says import, can't import name, set print options, right? Because it doesn't exist. There, we fixed it, and now it just works. All right, so let's move down to importing our file. Here is our variable, right? File name is just a container for the CSV. Remember, CSV is a comma separated values file, and it is the default file for all machine learning tutorials, this one included. Down here, we've got a data frame, and it's also a variable. And we're going to use read CSV to read the file name, this file name, into this data frame. Pretty straightforward, so hit Control Enter to do that. Remember when I said that you're going to take this notebook, this file that I'm going to give you, and import it into working directory. Additionally, when I first saw this, when I began learning Python, and it said file name BBC, or well, how does it know where that file is? I mean, there's no path there. Well, because we've put this CSV file into the working directory. And if you put it into the working directory here, this gives us our working directory. So we hit Control Enter. You can see my working directory is Users West. If you put this CSV in here, it knows. You don't have to give it a path. It knows that you have placed that bbc.csv in the working directory, and it can read it straight from there. All right, so let's go and navigate down to take a look at what we've imported. So we've got our CSV file read into our workspace, so to speak. All right, here I wanted to show you if you didn't want to put the CSV in the root, or if it was somewhere else, here is how we navigate to this folder, right, in order to read the CSV file. Now, keep in mind that we're reading this not from what many would expect would be like the C. So this is not the root of C. This is the root of the user directory. So this isn't in C. Let me show you. Let's go ahead and add. This really is C \users \m users \mwest /data files. That is actually where the CSV would have to be placed, right, for it to be read into our data frame over here. All right, let's go ahead and remove that. I just wanted to show you that. All right, let's navigate down to reading our data frame. All right, so remember up here, we've said data frame is read CSV. All right, so that's the name of our variable. So if we come down here, we're going to say, let's read the information that's in our data frame. And here we have this head function. So we're going to read the top two rows in our data frame. So we can Control Enter, and there are the top two rows, right? Pretty straightforward. So the number we put here, how about we read the top 5? Will allow us to see what number of rows we want to read. Now, what if we wanted to read the last 5? Well, fortunately for us, there is a tail function. So dataframe.tail, and we go Control Enter, and now we have the last 5 rows. And you can see we have 18,483 total rows in our data set. All right. Let's move down to the shape of our data set. Now, what's that mean? Well, it's just a lot easier to explain it. So we're going to put this cursor here inside our cell. We'll hit Control Enter. And now the shape is the number of columns and the number of rows, all right? Or the number of attributes and the number of observations in machine learning speak. So you can tell we have 884 rows. Well, why is there 3? Remember, 0 counts. And we have 12 columns. 1, 2, 3, 4. I'll let you count them. But we do. I promise this is correct. All right. So the shape allows us to look at the number of rows and columns in our data. All right. All right. Let's move down to describe. All right, so now we know the number of rows and columns in our data. Let's go ahead and look at this describe function. And the describe function is going to give us the mean, median, mode about all the rows in our data set. So again, we just click on the cell, we hit Control Enter, and now we have a whole bunch of information. Well, it's going to give us the mean, median, mode and some additional information, right, about our data set. All right? So describe gives us information about our data, right, about all of the attributes.
All right, in this lesson, let's continue building our model. Python has a number of data types called composite data types. Composite data types are those that can hold more than one value. In Python, they are called lists, arrays, and vectors. The terms are often used interchangeably. The values of a list or array are ordered. That means you and I can easily access them. So here we have an array that holds the information for our data set. Here we have an array that holds the information for our target variable. All right, so let's come over here and create an array. We'll call this array X, and it will hold some stuff. Actually, it's going to hold some numbers. 0, 1, 2, and 3. There's an array. It's an array of numbers. It's ordered. We can access any element in that array if we come over here and say X, the second element in our array is equal to 1. Why? Because 0 is the first element in an array, and that is the second element in our array. It's simply an ordered list of something. And in our case, that something is numbers. Well, how do we know it's numbers? Well, because the entire data set is numbers. That's how we know it's numbers. Notice I have this word accuracy, all right? And it says accuracy is, we have to move up to get the definition. I covered it up with my data set. Accuracy is only really useful when there is an even distribution of values, all right? Well, that's great. The good news is if we use the print data frame group by like target, look, this is our target variable, and that corresponds to right there, right? We can see that there is a relatively even distribution of buyers and non-buyers. Remember, there's our non-buyer, and there is our buyer. That means we can use accuracy as a metric for determining, if you will, the accuracy of our model. So you may be thinking, well, wait a minute, what is accuracy? Well, accuracy, let's see if I got a little space here. Yep, let's see if I can do it here. Accuracy is simply the number of correct predictions. We'll call it correct preds, all right, over the total number of items in our data set, right, times 100. So let's say, let's come up here. Here we got some white space. Let's say we have 201 correct out of 286 observations, right, times 100 would be equal to 70.28%. That would be our accuracy. You're going to see accuracy used often, actually very often, and you're going to see it misused often. However, in our case, accuracy is a great starting point when we have class balance, right? Rarely do you have class balance. Most of the time you have class imbalance, where these are way off from one another. Here we have class balance, so we're going to use accuracy as the starting point for evaluating our model. All right, so in this lesson, let's continue to step through our model. We're almost done. So up here, we're, remember from means we're bringing something into our canvas here, right? And what are we bringing? We're bringing in this function and this SVC, right? Which is what? An SVM. Wait a minute, what's that? An SVM is a support vector machine, right? That's the name that we use outside of sklearn. Because SVC stands for support vector classifier. Keep in mind that all the models inside sklearn are called classifiers. You can't forget that. All right, so most of the time you're going to see SVM and sklearn, it's support vector classifier. Exact same thing. All right, so here we're going to bring in the train test split. We've already discussed what that is. So here is going to be our test size, and here is going to be our training size. And here is where we define the test size. Why? Because it says test size, and we simply pass test size into our test train split function, right? That we brought in up here, right? And 25% is going to be for testing, right? So that means 75% is going to be for training, right? Pretty straightforward. Here we have a random seed. Again, this is for reproducibility. Up here I have it as a 7. You could put any number there you want, right? So one of the last steps we're going to take is to define our model. What model are we going to use? Well, up here we brought in SVC, right? A support vector classifier. So that's a pretty good indicator that we're going to use a SVC as our model. And down below here, actually let's make that a big arrow. Down below here, we're going to bring in other models. For now, it's going to be the support vector classifier. All right, in this lesson, let's finish the model building process with 3 lines of code. And again, this is what makes Python so great. And actually, the libraries that we use to import into Python is the simplicity. So we're going to fit our model with 1 line of code. All right, model fit X, Y, Y train. The results, score it. Again, model score X test, Y test. Again, it's a function. And then we're going to print the accuracy of it. All right. So in 3 lines of code, we're going to basically fit, which is train our model. We're going to score it, and we're going to print the accuracy. And that's it. And we're done. Let's come down and look at the whole thing. When you look at it this way, it really is simple. All we did in the lessons is to walk through each line of code so you know exactly what's going on. So let's go ahead and put our cursor there, and let's hit Control, hold Control down, and we hit Enter to see the results of our model. And it looks like we have a 77.53% accuracy using the random forest classifier. All right, let's move down to the next frame and use another model. And here, instead of random forest classifier, all we have to do is copy the name. So let's go Control C, let's come down to, remember they're all functions, so all we have to do for a lot of the models that are similar is copy out the function name. And that's it, right? Because we're specifying the model parameter here, everything else is the same. So let's come down and now try our entire model with the 𝐏_neighbors classifier. Control Enter. Let's see how well it does. All right, not bad. It beat our previous score. All right, do we have anything else? I think we brought in SVM. All right, let's try it with the support vector machine. All right, again, all we have to do with these similar models is SVC, right? Support vectors classifier. Come down here and hit enter. Now you may be thinking, well, can't we do it all at one time? Yeah, but this is much easier to learn. An SVM takes a little longer, so it's running. And here we go. Very similar to our 𝐏_neighbors. And again, look how simple it was. So all we had to do to use a different model was import it, right? Import a different model. And then in this example, simply switch out the name of the classifier, leaving the parentheses there. These parentheses denote that it's a function, right? So we're calling each of these and placing it into the model variable, and that's it.